And now I would like to invite our second keynote speaker, the Bioenergy Technologies Office Program Manager, Department of Energy USA, Jim Spaeth.
Boa tarde. I tried to learn Portuguese about 24 years ago before going to Mozambique. And when I got there, they told me that I was speaking Brazilian Portuguese. And I said, what do you mean? There was nothing in my book published in the United States that said anything about Brazil. But I guess they figured that anyone learning Portuguese in Brazil or in the US is going to Brazil. But I didn't make it to Brazil until actually last year. I was all set to come to BeBest in 2020 and was severely disappointed when it was canceled, like many of you, I'm sure. So last year I made it to a Clean Energy Ministerial meeting in Rio, and then that was my first time, and now this is my second time in the month of October coming to Brazil because I had the privilege of coming to the G20 and Clean Energy Ministerial meetings in Foz do Iguaçu a few weeks ago, and to participate in the Clean Energy Transition meetings, the Energy Technology Working Group meetings, and the SEM. And as Ambassador Delago just described, we had some wonderful meetings on biofuels and future fuels, sustainable fuels. And I also had the privilege of seeing the Itapu Dam, amazing, and the Foz do Iguaçu, which are incredibly spectacular. So if you haven't seen them, I highly recommend it. But now to what I'm here for. It's a pleasure to be here talking to you this afternoon. I appreciate the invitation on behalf of the Department of Energy. And it's also a privilege to be working with folks like Laiz Garcia and Ambassador Delago, who I work with through the Clean Energy Ministerial, and Laiz's predecessor, Renato Godinho, who I worked with for many years with the creation of the BioFuture Platform Initiative. But I'd like to talk to you today primarily about not just biofuels, but specifically about sustainable aviation fuel and the bioeconomy. I know these two topics are of great interest to you all and to Brazil. The U.S. has been on a biofuels journey for many decades, similar to Brazil, and I know, like Brazil, we're now on a journey together and globally on SAF and on the bioeconomy. So I'd like to give you a little bit of the history just of the last few years of the journey since 2021 that we have had in the U.S. on SAF and the bioeconomy. So I'd like to start with, on January 20th, 2021, President Biden was inaugurated into office. And on that day, he committed to a number of very important things. He committed the U.S. to regaining a role of international leadership and collaboration on the climate and recommitting the U.S. to the Paris Accord. So those were very strong, very explicit early indicators of the commitment and the intentions of the U.S. when it came to climate. On Earth Day that same year, he held a Global Leader Summit, and he declared some additional important things, like committing the U.S. to a clean grid by 2035 and to electric vehicle penetration in a huge way by the early 2030s. And then on Earth Day that year, that was Earth Day, but later that year, I'll get to the story about where we are on SAF. So a little bit of perspective on the U.S. In the United States, transportation is the largest end-use sector in terms of GHG emissions, by far over all the other end-use sectors. And this administration is committed to a completely net zero economy-wide system by 2050. Transportation, though, is a very challenging sector, as you all know. I was surprised to learn that, at least in the U.S., we spend half of all of our energy dollars on transportation, and it creates half of all local pollution. So it is a huge challenge and a huge problem. It was in this context that in September of that same year, 2021, that the White House and a number of different U.S. government agencies came together to declare what's called the Sustainable Aviation Fuel Grand Challenge. So in this Grand Challenge, Our key goals are, by 2030, to have 3 billion gallons of domestic SAF production with at least 50% GHG reductions in that production. And then by 2030, by 2050, displacing all fossil jet fuel with sustainable aviation fuel. This chart is one among many that present this picture of that there are a number of things you can do for aviation to clean it up: operational improvements, aircraft efficiency improvements, engine improvements, on-ground improvements. But the green wedges show, the darker green wedge, the impact that can be made with 50% GHG reduction SAF, and the more hatched wedge of green with 100% GHG reduction on SAF. So our bottom line goals are at least 50% GHG reduction, but really we want to aim for way beyond 50% and going to 100% and beyond. The Sustainable Aviation Fuel Grand Challenge has actually 8 different U.S. government agencies involved in it. I've personally never been involved in my career in something quite as cross-agency oriented and as effectively cross-agency oriented. So participating agencies include, for example, NASA, which is very involved in aircraft efficiency improvements, the Department of Defense, which has a great R&D budget but is also a great off-taker of aviation fuel. But then more specifically, and the biggest roles are being played by the Federal Aviation Administration, the U.S. Department of Agriculture, and the DOE. The Federal Aviation Administration, which resides within our Department of Transportation, has been leading aviation initiatives in the U.S. forever, for always. It goes back to the 1950s when it was created. So they have been looking at the SAF opportunity literally since about 2005. It has been in their radar screen. Unlike some of the other agencies, my own included, SAF is not a new concept. It's not a new thing. It's a very important initiative that has just received significantly greater attention under this administration in a very positive way. The U.S. Department of Agriculture, of course, is focused on feedstock creation, feedstock diversification, feedstock handling, storage, and getting the feedstock needed to where it needs to be. And the U.S. Department of Energy, my home agency, is more focused on how to use that feedstock, how to process it once it's out of the field, and in particular conversion technologies, which I'll speak a little bit more about going forward. There are a number of ways to provide energy into a jet to get it to fly. SAF being the one that, as the previous chart indicated, we expect to have the most impact between now and 2050. There's also e-fuels, hydrogen, electricity in its various forms. All of these are being worked at the Department of Energy. But I come from the Bioenergy Technologies Office, and I'll be speaking primarily about biogenic-based SAF. So as I mentioned, the Grand Challenge was declared in September of 2021. A year later, in September of 2022, we released what is called our SAF Grand Challenge Roadmap. So this is an all-of-federal government approach to laying out what we think are the actions required to get to our 2030 and our 2050 goals. So it has 6 different sections focusing on the different key areas of technical challenges. First, feedstock innovation and development. We need a wide range of feedstocks, not just a single one. I think that applies in almost every country, to meet the goals that we have for SAF. Conversion technology improvements. We need to increase the efficiencies and lower the cost of conversion technologies. There are numerous pathways that are being custom tuned to various feedstocks. So as probably everyone in this room knows, it's technically a very challenging space. Building supply chains. In the U.S., similar to Brazil, we primarily have biofuel supply chains for ethanol, Gen 1 ethanol, primarily corn in the U.S., I know primarily sugarcane here, and biodiesel. So now we need supply chains for many different other types of biofuels for SAF, and those supply chains simply do not exist at the moment. Policy. Probably we all recognize that in these early years of new clean technology creation and market creation, we need strong policy support. We also need to enable the use of these new fuels. That's enabling end use involves things like the ASTM qualification of these fuels, that ASTM being done for fuels all around the world. And communicating progress and receiving feedback from the entire ecosystem that is working on this challenge. Very soon, we're going to be published what we're calling our SAF Roadmap Implementation Report. And this is an internal survey of, so we laid out a roadmap of what we think needs to be done. This implementation framework will provide an analysis of the types of programs that we currently have and funded areas that are directed towards these different research challenges. And also will highlight where there are deficiencies, where we know there are actions needed, but we're not currently working on them. So that will be released hopefully very soon, and it will be a very insightful document. We also will be releasing a progress report on SAF soon as well. And next year we hope to release an update on the roadmap. So more to come, but now to talk a little bit more about actions and opportunities. In the pie chart that I showed previously, it showed these green bars. This is just the transportation segment. But looking at this graph on the left, it's the current forms of fuels that we use, distillate, diesel, jet, gasoline, et cetera. The colored bars are the same bars as in the transportation or in the GHG pie chart. So the green bars are light, medium, heavy-duty vehicles, which we expect to be largely electrified over the next decade. So it's these remaining colors, orange and below, where we have like off-road, rail, aviation, and marine uses of biofuels, where we need help from bio-based fuels. And we need a lot of feedstock and a lot of these biofuels. And a question for us and a question for the world is, are there enough of these feedstocks out there? And for the US, we think the strong answer is yes. We published in March of this year what we call our billion-ton study. This is actually the fourth year we've done, or the fourth revision of the billion-ton study that we've done over almost the last 4 years. And it provides a detailed analysis of all the feedstocks available that can contribute to SAF and to other biofuel applications. We think that not only is there 1 billion tons, but close to 1.75 billion tons possibly available for development by 2050. And we think this could be translated to well over 60 to 70 plus billion gallons of various biofuels. So we think the answer is a resounding yes, that we can produce enough SAF and enough biofuels to meet these many challenges. And in the US, like Brazil, we have a wide range of different feedstock resources, different types around the country, very different climate zones, different elevations, everything from pine trees in the southeast to different types of trees in the northwest, row crops, soy, corn, et cetera, in the Midwest, and everything in between. So as I mentioned previously, we need to use a wide range of different feedstocks. Hence, we need this feedstock development and conversion technology development to be able to use these various resources and to get to the higher volumes. This chart shows that we'll use approximately these types of resources. We're currently using fats, oils, and greases for HEFA, SAF technologies. And of course, we're using corn currently for ethanol. But we have a big push on, and we may have, before the year's out, our first production of alcohol to jet at a commercial scale in the US this year. There's a lot of interest and a lot of work going on right now in municipal solid waste and wood waste usage for SAF. And beyond that, though, we need a great deal of additional uses of agricultural waste. In the US, that would include items like corn stover and wheat straws and various other residues. And eventually, we expect other dedicated energy crops and algae to contribute to that over 1 billion tons that is needed every year. When it comes to conversion technologies, the US DOE tries to insist on having a very steady and stepwise scaled approach to technology development. Like Brazil, we've spent the last several decades developing 2G ethanol. Some of those large investments were not successful. At times, that was caused by trying to rush too quickly between steps, perhaps not doing enough research at the bench scale, or not enough piloting of various technologies, or skipping completely demonstration scale steps. Well, we've learned hard lessons and seen billions of dollars spent between the US government and various industry partners in those 2 decades of what can happen if you don't scale carefully. So we try to insist now with our project partners that we scale carefully. So in terms of scaling up SAF, we are hoping to help fund with private industry at least 4 or more new feedstock to conversion technology pathways by 2030 through the demonstration scale. And this chart just represents at the pilot and demo scale the various end uses of projects that we're funding at these two scales, SAF, renewable diesel, et cetera, even e-fuels, and the various types of feedstocks and the logos of the industries, the various companies that we're working with, just to give you a little teaser. I also wanted to mention, and if you follow the U.S. biofuels program, you're probably aware of this, but out of the Inflation Reduction Act, bioenergy, biofuels, and SAF received two major things. They received some great tax credits that I'm sure will be discussed during policy sessions during this week. And also the FAA received about $300 million for a grant program to invest in the technologies and infrastructure to move this forward. So just on August 16th, these awards were announced, almost $300 million worth of effort for supply chain development, infrastructure projects, low emission technology development, and developing test capabilities for these new fuels. Now I'd like to turn briefly to the topic of the bioeconomy. Like Brazil, the U.S. is very interested in the bioeconomy. We also took part in the G20 bioeconomy meetings, working group meetings that have been held during the course of the year. I've been following it from the sidelines. I wasn't personally involved, but great to see the progress there. But the U.S., like Brazil, has a very broad view of what the bioeconomy can be and what it can contribute to just economic development across the country and worldwide. So when we talk about the bioeconomy, we're talking about many different sectors: health, energy, chemicals, materials, agriculture, food, and supply chains in general. So we have, like the SAF Grand Challenge, we have a bioeconomy vision that is pushing for use of these various biotech and biomass resources to reach at least 85% GHG reduction, and to use that to help spur economic development. So we think that with the use of the various scientific and technical capabilities within the U.S., combined with investments in R&D and manufacturing and new test facilities, that we can help stimulate many different products to create markets and manufacturing supply chains that grows the U.S. bioeconomy, but also grows the entire global bioeconomy. With this billion tons of biomass used differently, we could create the 60 or more billion gallons of fuels that we mentioned, or we could use some of that for, we estimate, up to 200 million tons of various biochemicals and bioproducts, and produce over 450 million metric tons of GHG reductions, and to create at least 1 million jobs. So for us, it's a very, very exciting opportunity. It needs further development, just like SAF does, just like biofuels do for second, third generations, but we think it's very promising. And we hope that this can be stimulated with the help of various testing centers, pilot testing facilities that the U.S. government can help set up in partnership with private industry. And as an example of this concept, this idea, there is a facility called the Advanced Biofuels and Biochemicals Process Development Unit, and this is a picture, that was built about 12 years ago at the cost of about $50 million at Lawrence Berkeley National Laboratory, which, if you don't know where Berkeley is, it sits across the bay from San Francisco, so very easy to find. But as I mentioned, it had about a $50 million initial investment. We invest about $2 to $3 million annually each year in its maintenance and upkeep. And it has partnered with numerous different companies to create an initial economic value of $2 billion. So $50 million has led to economic value creation and investment of $2 billion end-to-end new technologies for the various companies that we have worked with. And other companies we've worked with for parts of their technology development, and it's stimulated as much as close to $5 billion of investment. So this is a terrific example that we hope to replicate in the U.S., $5 billion being 100x return on our $50 million. So wrapping up, turning back to SAF. This is a chart of U.S. SAF production and consumption, excuse me, not just U.S. production, but U.S. SAF production and imports. So in 2021, we used approximately 5 million gallons of SAF total in the U.S. In the first 6 months of this year, the U.S. has produced and consumed over 50 million gallons of SAF in the first 6 months of this year. So a great increase. You can see yourself in the bar charts that SAF is literally taking off. We estimate, based on the projects announced and a little bit of a reality check, that by 2030, the U.S. could have within its borders between 2.5 billion and 5 billion gallons of SAF production. And that doesn't count for imports and exports. So we think that those grand challenge goals are possible. We also estimate that if we reach the 3 billion gallons, just within the first 6 months of this year, we estimate that this 50 million gallons has saved about 300,000 metric tons of GHG. So this is the path that we're on. We know Brazil is on a similar path. I'm very excited about the future fuels announcements and initiatives. I'm very excited about the U.S. working with Brazil and some of the other countries represented in this room on creating this SAF global ecosystem, because no single country can have a successful SAF industry just within its borders. This is truly going to have to be a global industry. So I hope you've enjoyed and learned something here. I look forward to speaking and meeting with many of you this week and being on this journey with you towards creating the SAF and the bioeconomy of the future. Obrigado.